We now convert the rectangular equation to polar equation. So for this, we utilize the polar conversion, that is, in polar coordinates, x is basically r cos theta and y is basically r sine theta. So replace x by r cosine theta. So therefore this becomes r cosine theta 20 square plus replace y by r sine theta. So it is r sine theta 20 square, and this equals here replace x by r cosine theta, so it is r times cosine theta, and so this gives the square of this is r squared cosine squared theta plus the square of this quantity is r squared sine squared theta, and this equals r cosine theta. Now on the left side we can factor out r squared from both terms, so we will have r squared times of cosine square theta plus sine square theta, and this equals r cosine theta on the right side. Now we can use the Pythagorean identity. So according to that, cosine square theta plus sine square theta equals 1. So therefore the left side simplifies to r squared times 1, and this equals r cosine theta, and so this equals r squared equals r cosine theta. Now we divide the both sides by r, so we get r squared divided by r, and this equals r cosine theta divided by r. We can simplify this using the exponent clause. So here it will get reduced to 1 power r power 1, which is r, and this equals these two r's will get cancelled. So we have only cosine theta on the right side. So we end up with this polar equation, that is r equals cosine theta. This is the polar equation.